All right. So for today's lesson, it's going to be pretty short. I'm not going to lie to you. So the assignment is a little bit longer for this one, just for good practice, honestly. Make sure you guys feel comfortable making your formulas. So yesterday we did word problems, right? We were building formulas based on the situation that we were kind of dealing with. Today, you don't have a specific word problem, you just have a table. And you're going to make a formula from that. And then also, we're going to talk about the difference between linear and exponential. And I'm going to kind of introduce some new words to you. We're going to get into something new next unit that's a little bit new and different. And that'll be next week at the end. So just going to kind of hop around here. So first things first, head to your notes. The sub should have passed them out. As far as going to find the differences, we're going to start with equations first, then we'll kind of head over to the tables. So, anytime you have like a y equals mx plus b equation, or it could be in, like standard form. Remember we learned standard form last try. So that's standard form. And this right here is slope-intercept form. These are all linear equations, okay? Basically what it means is there's a y and an x. So anytime that's the case, it's just going to be linear. So if I look at the first one, that's linear. If I look at the next one, that's linear, because I already told you that. If I look at number 2, it's linear. You got an x and a y. If I look at 10, has an x and a y. If I look at 7, if I look, I think that's all of them that are linear, okay? Now, as far as exponential goes, we've kind of talked about the form, which we did that, so that today would be a little bit easier. Anytime you have x as the exponent, it's going to be exponential, 9 times out of 10, okay? So this is exponential. This one's exponential. They just have x as the exponent. Okay. This one's exponential. Exponential. And then these last ones, when it's x minus something, we kind of did an example like that on Tuesday. That's also going to be exponential, okay? And then as far as these last two, do you guys see how the exponent is a number? These we call quadratic or cubic functions. You don't need to worry about these for a minute till next year, okay? But basically it means that the exponent is a number, not x. So in this case, these are both neither. And that'll happen. Right? Not everything's linear or exponential. There's other things in the world, right? So you'll spend the rest of your high school career figuring those out. Okay, so as far as linear or exponential goes, remember linear is constant growth. So I'm growing by a plus or a minus. I'm adding 5 or subtracting 5 each time. Exponential growth, it's being multiplied or divided, okay? And it also is constant growth, like it's multiplying or dividing constantly, I guess, so you could say that for both, but linear, you're adding or subtracting, and then timesing or dividing for exponential. Now, I'm just going to throw these vocabulary words at you now, because we're going to talk a ton about them in about a week, but it's necessary kind of for your assignment today on derivative. So, as far as linear goes, we use the word arithmetic. Okay, so anytime something's arithmetic, it's linear. Anytime something's exponential, we call it geometric. Okay, these words you'll need to know. Okay, so like on your assignment, it might ask, is it arithmetic or geometric? It's just asking if it's linear or exponential. Okay, so just keep that in mind. Now, when we're talking about arithmetic, whatever we're adding or subtracting, we label as the difference, so D. And so that will be whatever you plus or minus, and then R is your rate, and that's whatever you multiply or divide. So that's a lot of vocab for your Thursday. Or Friday, or whenever you're watching this, right? As far as arithmetic and geometric go, we just need to figure out what we're adding or subtracting. So I'm just going to do a few so you guys can see. So the first one, number 13, looks like I'm minusing 2 each time. And since I'm minusing 2 each time, that's arithmetic, right? And so that's going to be linear. And my difference is negative 2. Let's just do a few more. This next one, it looks like I'm adding by 5 each time. So that's linear. And my difference is 5. This next one I'm timesing by, it looks like 2. And so this one's geometric. And my R is 2. That's what I'm multiplying by. Okay, and we'll talk about, arithmetic and geometric. I'm just getting the vocab out there so you guys can kind of think about it. We also call that 2 the B right now, currently. That is also the B. Now, if you look at this last one, it goes down to 1 and then up back to 6. That's neither. Not going to be either of them. They're not growing at a constant rate or decreasing at a constant rate. The last one we'll do here is this one. And remember, if you don't know the difference, you can always do the second one divided by the first one, and it'll tell you. So if I do the first one on the bottom and the second one on the top, I end up getting a 10th. So I'm dividing by 10 each time. And so my rate is going to be 1/10. So what I'm dividing by is 10. And that's geometric. So keep in mind, you're never dividing, really. You're just multiplying by a fraction. So you're either multiplying by a number or you're multiplying by, a fraction. A number over a number. You're never really dividing. You're just multiplying by fractions. That's kind of the secret to math, honestly. Okay, so that's kind of the idea behind that. So you're going to look at tables. You're going to tell me if they're linear or exponential, which we also use the words arithmetic and geometric. Sorry, I use them interchangeably all the time. So linear, arithmetic are the same, exponential, geometric are the same. So this geometric one over here is also exponential. And these linear ones over here are also arithmetic. They had to just have 2 vocab words for everything, right? We'll talk about it next week. Okay, so those are kind of your first few. And then down here, we've got some graphs. Now, these ones are a little bit more obvious. Like, if it's a straight line, it's linear. If it's curved going up, just like we were drawing yesterday, that's exponential. And then anytime it's like a wavy something, it's going to be neither. Remember, exponential can also be decreasing. So this is exponential. This one's going down and up, so that's neither. And then as far as linear goes, this is linear. It's a straight line. It's just a horizontal line. So just kind of keep those in mind. So flip your page. There's a lot on this back. We're actually really not going to do much of it. You guys already know how to do these. We've already kind of talked about 49 as much as I want to talk about it. So we're just going to do a few examples from 29 to 36. You're going to have to write some formulas. We'll kind of chat about that in a second. But I'm just kind of reviewing from yesterday. And just kind of thinking about, is this linear growth, plus or minus, or is it exponential, multiplying, either by a number or a fraction? Those are kind of your options. So a gym's customers must pay $50 for membership. All right, cool. Plus 3 times they use the gym. So really the question becomes, is it more expensive as they keep going to the gym, or is it just $3 every single time? It's just consistent, add 3, add 3, add 3, and you're just starting at 50. So if I'm adding 3, adding 3, adding 3, adding 3, that's going to be linear. The next one, it says I start with $20, and every single month I triple my amount. Well, if I'm tripling, it's going to increase a ton, and then even more, and then even more, and then even more. So I'm timesing by 3, and then I'm timesing by 3, and timesing by 3. So that would be, and I'm starting at 20, by the way. Not like that super matters, but that's going to be exponential. Does that kind of make sense? So linear is just like that constant add, and then times is that exponential. 32 is kind of an interesting one, too. So I'm starting out with 20,000 owls, but every decade they half. Which remember, half is just times by 1/2. We kind of mentioned that on Tuesday. Just a little bit. So you're timesing by half, which is exponential. You're timesing by something. So that's kind of the idea behind those. So just kind of think, am I timesing, am I adding? And that's kind of the gist of that, okay? Now the last thing you'll be asked to do in your assignment today is I'll give you this geometric formula or whatever, or exponential, you can think of it either way, and I need you to write the formula, okay? So, for these, let me just peek really quick. Yeah. So for these, I'm just going to give you a really solid example. Let's do number 20. So what's happening each time? I'm timesing by 4. Okay. And what's my starting point? Well, my starting point is wherever 0 is. Okay, so my starting point is 1, because when I plug in 0, my intercept is 1. So my equation, and when you type it out, I think in derivative it says like g of x. Doesn't matter, you could use f of x, you can use g of x, you can use y, just use whatever they want you to use. I think in derivative it wants you to use g of x. And so you'll say g of x, you'll start with your intercept, which is 1. Then this is your a, and this is your b to the x, right? Like the formula says on the board, okay? Intercept is a, b is your multiplier, so 4, and then to the x. So that would be your equation. Let's do another one. Let's say same thing. Let's do -1, 0, 1, 2, 3. Let's say it's like 1/3. I want to find a different number. Let's say 2 is here. Let's say 2/3, and then let's say 6, and then let's say 18, and then let's say it's 30 plus 24, 54. So if I take a look at this, starting is 2, so g of x is equal to 2. I'm multiplying by 3, so 3, and then to the x. That's it, just like we did yesterday, okay, just on a table instead. So I want you guys to just head over to your assignment, get practicing those. It really shouldn't take too long, but there's kind of lots because they're a little bit short. So I'll see you guys tomorrow. Help each other out if you guys need, by the way. The sub can't probably help too much, so make sure that you're helping each other out if you're done. Thanks.